Once more, you are welcome to our revision classes on Sanji Academy. We will be looking at Ordinary Level Physics 2018, June 2018, Ordinary Level Physics. For now, we're going to look at, we're going to answer all the questions. This first section is section 1. I want us to do section 1 completely. So we'll be snappy, but we'll be straight to the point also. The first question, question 1a, state Faraday's law of electromagnetism. State Faraday's law of electromagnetism. Faraday's law of electromagnetism says the induced EMF or the induced current is directly proportional to the rate of change of magnetic flux. The induced EMF is directly proportional to the rate of change of magnetic flux, or it is directly proportional to the rate of cutting of the magnetic field lines. Directly proportional, the induced EMF or induced current is directly proportional to the rate of cutting of magnetic field lines. The next question says, state Lenz's law of electromagnetism. Lenz's law of electromagnetism states that the induced EMF or induced current flows in a way, or the induced current flows always in a way such as to oppose the change producing it. The induced current flows in a way such as to oppose the change producing it. Now, the next question says a transformer in a radio set delivers 5 amperes at a voltage of 6 volts from a socket connected to a 240 volt line. A transformer in a radio set delivers 5 amperes at a voltage of 6 volts from a socket connected to a 220 volt line. Question number 1, state whether this transformer is a step up or a step down transformer. State whether it is a step up or a step down transformer. It is definitely a step down transformer because it is converting 220 volts from the socket to 6 volts needed by the battery. So certainly it is a step down transformer. What actually we consider to be step up or down is the voltage, not the current. When the voltage changes, you read whether the voltage has increased from primary to secondary. Is there an increase in voltage? Then it's a step up. From primary to secondary, is it a drop in voltage? Then it's a step down. It is the voltage that tells us whether it is a step up or a step down transformer. Assuming the transformer is 100% efficient, calculate the amount of current that enters the socket. Assuming the transformer is 100% efficient, calculate the amount of current that enters the socket. The amount of current that enters the socket. If the transformer is 100% efficient, then we are saying that power input is equal to the power output. This is the power at the primary coil and the power delivered by the secondary coil. This is power is V voltage by the primary times the current at the primary should be equal to the secondary voltage times the secondary current. Now, from what we have been told, we are told that the radio, which is the secondary, needs 5 amps and 6 volts, while the primary voltage, the voltage across the socket is 240 volts. So what we are looking for is the primary current. So the primary current is what we are looking for. And so if we substitute here, we will have the primary current, which is the secondary voltage times the secondary current divided by the primary voltage. This is what do we have here? We have 6 times 5 divided by 240 volts. 6 times 5 is 30 So 30 divided by 240 will give us 1.25 amps. 1 will give us what? 0.125 amps. So that is the current. That's the current that will be fed into, or the current that is being drawn from the socket. The current drawn from the socket. Now, as I was telling you, you see that the current into the radio is 5 amps, and the current from the socket is 0.12 amp. When the voltage is stepped up, the current is stepped down, and when the voltage is stepped down, the current is stepped up. This was the current supply, and this is the current gain. The current supply is 0.125, and the current gain is 5, because it's a step down. So when the voltage is stepped down, the current is stepped up. Okay. The next question, number 2, state the law of conservation of linear momentum. State the law of conservation of linear momentum. The law of conservation of linear momentum is very simple. It states that the total momentum before collision is equal to the total momentum after collision, provided the external resultant force is 0, provided there is no external force acts on the bodies when they are interacting. Before interaction and after interaction, there is no external force, and so therefore the total momentum before collision is just equal to the total momentum after collision, provided the external resultant force is 0. Now we have a question to solve. A car of mass 1000 kilograms is traveling at a speed of 60 meters per second squared. A car of mass 1000 kilograms is traveling at a speed of 60 meters per second. And so we are asked to calculate what? We are asked to calculate the momentum of the body. The mass is 1000 kilograms, and the speed is 60 meters per second. We are asked to calculate the momentum, which is mv. So it is 60 times 1000, giving us 60,000 kilogram meter per second. That's the momentum of that body, 60,000 kilogram meters per second. Next question, it says if it crashes into a wall and is brought to rest in 0.5 seconds. If it crashes onto a wall, that is that ball, if that car crashes onto a wall and is brought to rest within 0.5 seconds, calculate the force it exerts on the wall. Calculate the force it exerts from the wall. Now, we know that from Newton's second law of motion, mass is equal to F is equal to ma, but the acceleration is the rate of change of velocity on time. It means the final velocity minus the initial velocity on time. And so therefore, we are saying that the force we have been asked to calculate is the mass times the final velocity minus the initial velocity on time. Now, the mass of the ball, the mass of the ball is 1000 into the final velocity. It is brought to rest. The car is brought to rest. So the final velocity is 0 and the initial velocity is 60. So this is 60 divided by the time. You say it is brought to rest for 0.5 seconds. 0.5 seconds. Now, if we then have our calculator, we shall have 1000. We shall have 1000 times minus 60 divided by 0.5. We will have we have 120,000 newtons. We have 100, it is minus 120,000 newtons. Why minus? First is that it's an indication that force is a vector quantity and has direction, and so the force is opposite to the direction of movement of the ball, the direction of collision. So the force is opposite, indicating that this is the reaction force. There is an action force, which is the ball, the car colliding with the wall, and this is the reaction force. Excuse me, my paper fell. Okay, we are looking at question number 3. State 2 physical properties of a conductor which affect its resistance. State 2 physical properties of a conductor which affect its resistance. 1. The cross-sectional area. 2. The length. 1. The cross-sectional area. 2. The length. Now, the cross-sectional area, the thicker the conductor, the lower the resistance. So the cross-sectional area, though that was not part of the question, is inversely proportional to the resistance. Then for the length, the longer the conductor, the higher the resistance. The longer the conductor, the higher the resistance. The thicker the conductor, the lower the resistance. So thick conductors conduct better than thin conductors, and short conductors conduct better than long ones. What are those two factors? Physical factors, cross-sectional area, and the length. Then the next question says, calculate the resistance of the circuit in figure 1. I think I should take off this so that we will see the figure, and that should help us to be able to calculate the resistance. We have, remember, we are dealing with June 2018, section A. We have like so. This is 2 ohms resistor. This is 3 ohm resistor. It is connected to a battery, and then the battery is in series with a 5 ohm resistor, and this battery is a 6 volt battery. Voila! So we have a 6 volt battery in series with a 5 ohm conductor, and both are parallel to, or both are in series to a parallel connection of 3 ohms and 2 ohms. So we have been asked to calculate the total resistance of this circuit. Total resistance, RT, is equal to the resistance in series plus the resistance in parallel. Now this is 5 ohms plus, the formula to calculate resistors in parallel is product divided by the sum. If there are 2, the product divided by the sum, it means 3 times 2. 3 times 2 divided by 3 plus 2. Now this is going to give us 5 plus 6 on 5. In my own way, this is on 1. To do it without a calculator, you make sure that the denominators are the same. The denominators are the same. For that to happen, you multiply this by 5 and multiply this also by 5. If you do this by 5 up and by 5 down, then you have not changed. If you multiply this by 5, you have 25 divided by, if you multiply 1 by 5, you have 1. You have 5 plus 6 on 5. Now they have common denominators, therefore you can add the 2. It is 31 on 5. We are calculating the total resistance, 31 on 5 ohms. 31 on 5 ohms. It is as simple as that. Or if you didn't know how to go through that and you choose to use the LCM, you choose to look for the LCM, you will still have the same answer. The LCM is going to be 5 5 divided by 1 is 5. 5 times 5 is 25, plus 5 divided by 5 is 1. 1 times 6 is 6. You're still going to have 25 plus 6, which is 31 on 5 ohms. So this is the total resistance of this circuit, the total resistance of the circuit. Then the next question, it says calculate the current flowing through the 5 ohm resistor. Calculate the current. To calculate the current flowing through this 5 ohm resistor, we see from the diagram that this resistor is in parallel to this cell. So all the current drawn from the cell will flow through the resistor. But how do we get the current drawn from the cell? From Ohm's law, V is equal to IR. It implies that the current I is equal to V on R. Now our V is R is 6 volts, and our R is this total resistance 31 on 5. 31 on 5. So what shall we have? We shall have 6 divided by 31 on 5. From our simple simplification from mathematics, we now have 6 times 5 on 31, which is going to give us 30 on 31. This is the current flowing through, this is the current drawn from the cell. So it is in amperes. That is the current drawn from the cell. And we are saying that this current drawn from the cell is IT, which is total current. Is going to flow in this direction, IT. When it comes here, it's going to break up into I1 plus I2. Now when it goes through these cells, it's going to connect through these resistors. It will recombine again to give us IT. So this 31 on 30 amperes is the current flowing through. It's all going to flow through the 5 ohm resistor because it is in series with the cell. So the current flowing through the 5 ohm resistor is 30 on 31. Now if we use our calculator, 30 divided by 31, we shall have 0.97. This is 0.97 amps. This is 0.97 ampere. That is the current flowing through the 5 ohm resistor. Now, question number 4 is very simple. State the SI unit of temperature and its lowest value. State the SI unit of temperature and its lowest value. The SI unit of temperature is the Kelvin and its lowest value is 0 Kelvin. The SI unit of temperature is the Kelvin and its lowest value is 0 Kelvin. Is 0 Kelvin. Next question. What is the thermometric property of a liquid in glass thermometer? What is the thermometric property of a liquid in glass thermometer? The thermometric property is the property that changes regularly with change in temperature. Is the property that responds to the change in temperature. And for a liquid in glass thermometer, it is the volume of the liquid in the glass that changes with change in temperature. When the temperature increases, the volume of the liquid in the tube increases. When the temperature reduces, the volume reduces. So the answer is what? What is the thermometric property? It is the volume or the length. Volume or length. Why volume or length? Because our volume is equal to the cross-sectional area times the length. Volume V is equal to cross-sectional area A times the length. But since the cross-sectional area is constant for a thermometer, the cross-sectional area is constant for a liquid in glass thermometer, it follows that V is directly proportional to L. So as V is increasing, L is also increasing. As V is reducing, L is also reducing. And so we can say the thermometric property is the volume of the liquid in the volume of the liquid or the length of the liquid in the tube. The volume of the liquid or the length of the liquid. If you say volume, it is correct. If you say length, it is still correct. State one use of a mercury in glass thermometer. It is used in the hospital. It is used in the laboratory. In school laboratory, it is used. And also in the hospital, it is also used to take temperatures. Now, the next question. A liquid in glass has a fine ball, a thin-walled bulb, and a blackened bulb. Explain the significance of the underlying words to the effective functioning of the thermometer. To the effective functioning of the thermometer. It has a fine ball. Fine means small. Fine ball. It has a thin walled bulb. It has a blackened bulb. Now, if you just permit me sketch this thermometer of a thing, it is like this. That is just a sketch, and yes, that is a sketch, and this is what they are telling us about this thermometer. They are saying that it has a fine bulb. This bulb is thin. This bulb is thin, very small, and it has a thin walled bulb. This is the bulb. B-U-L. It is thin also. It is also thin. It is not thick. Now, it is also, again, it is darkened. This bulb is darkened. Now, the question is, why is this bulb thin? What makes it effective? How is this, the thinness, the fineness of this bulb makes it effective? It makes it sensitive. It makes it sensitive. It can respond to the slightest change in temperature, because once the temperature is rising, the mercury level is also rising. When the temperature increases, if this, you slot it maybe in a block, as the temperature increases, as there's a change in temperature like increase, the mercury runs up here. It is so small so that any slight change in temperature will be noticed as the volume increases or drops. So it is to make it sensitive. It makes it sensitive. Then why is this bulb thin? Why is this bulb thin? It is thin so that it can absorb rapidly. It should not store much heat here. If it was thick, then it will store some heat before it could even heat up the mercury in here. So it should conduct fast. It should conduct heat faster. Now, why is this bulb blackened? So that it should absorb well. It should absorb heat well. You know, black bodies are good absorber. It conducts heat. It conducts heat faster, and it is blackened so that it can absorb heat well. Beautiful. Okay, that said, we are looking at question number 5. Figure 2 shows a parachutist falling freely from a great height until he hits a constant velocity. Figure 2 shows a parachutist falling from a constant height until he hits a constant velocity. Before we go answering the question, it is good that I put a sketch of the figure on the board. It is not drawn to scale. So this is like a parachute. And then this is like this guy is hanging on it. This guy is hanging on it. This guy is hanging on it. So this is the parachute. I hope you can catch my diagram. So that is the guy. It says this is the parachute. Figure 2.0 shows a parachute is falling freely from a great height until he attains a constant velocity. Question number 1. What name is given to this constant velocity? It is called terminal velocity, constant velocity, terminal velocity. Copy figure 2 and indicate all the forces acting on it. Luckily we have it. So this is going to be the weight, W. You can spell it out. This is the weight. This is going to be the up thrust, and then this is going to be air resistance or drag, air resistance, or the drag force. Air resistance or the drag force. Copy the diagram and indicate all the forces acting on it. We have the weight downward, we have the up thrust, and we have the air resistance. Which of these forces increases with speed? Which of these forces increases with speed? It is the air resistance. Air resistance. Which of these forces increases with speed? Air resistance. Air resistance is the force that increases when the speed of a body moving in air increases. Air resistance is the force that increases when the speed is increasing. So that answers that question. What is the net force on the body when the velocity in I1 is attained? It means, what is the net force on the body when the body attains terminal velocity? What is the net force? The net force is 0. Net force means resultant. It means resultant. The net resultant is 0. Why? Because the total upward forces are equal to, the sum of total upward forces are equal to the sum of downward forces. It means that by symbol W is equal to this air resistance plus the up thrust. W is equal to air resistance, is the W, which is the weight, is equal to the up thrust and the air resistance. So when the up thrust is equal to the up thrust plus the air resistance is equal to the weight, it attains terminal velocity. There is no acceleration. When a body is not accelerating, certainly it is moving under constant motion. It is that constant motion that is called terminal velocity for a falling body. Explain what will happen to the time. What will happen to the time to attain the constant velocity if a larger parachute was used? It means if you use a larger parachute. If you use a larger parachute, what will happen? The up thrust will increase. The up thrust will increase. So with increase in up thrust, the time to attain constant velocity will be reduced. Explain what will happen to the time. One, the time will reduce. Why will it reduce? Because a larger parachute means a larger surface area, and up thrust is a force that is directly proportional to the surface area or the volume of the body. Therefore, larger surface area increases the up thrust, and that will reduce the time to attain constant velocity. Question number 6, and I'm sure is the last in section 1. State the difference between distance and displacement. State the difference between distance and displacement. Distance is a vector quantity, displacement is a scale. Distance, is a scalar quantity, and displacement is a vector quantity. Distance is a scalar quantity, displacement is a vector quantity. A scalar quantity is a physical quantity that has only magnitude and no direction. But a vector quantity is a physical quantity that has magnitude in direction, magnitude in a particular direction. Okay. Define velocity and state its unit of measurement. Velocity is the rate of change of displacement with time. The rate of change of displacement with time, and the unit of measurement is a meter per second. Now we have the last diagram. And we will be done with section A. We have the last diagram. Remember, we are looking at June 2018, ordinary level physics. June 2018, ordinary level physics. Figure 3.0 shows the velocity time graph for a cyclist in a race. This is the figure. It shows, this is the time in second. This is the velocity in meters per second. Velocity in meters per second. The body moves like this. like so, and then like so. And we have, this is A, B, C, and D. Yes, A, B, C, and D. It has just this question. Describe the motion of the cyclist in the section A, B, and B, C. Describe the motion of the cyclist in the section A, B, and B, C. Certainly, A, B is to describe it. The rate of change of velocity is constant, and therefore it is constant acceleration. The rate of change is a straight line. The rate of change of velocity with time is constant, and so therefore it's constant acceleration. BC is constant velocity, because while time is passing, the velocity remains the same. BC is for constant velocity. And lastly, state the significance of the gradient of the section AB. State the significance of the gradient of the section AB. The significance of AB. What is this gradient? What is this gradient equal to? The gradient is the acceleration, because acceleration is a change in velocity over change in time. The gradient is the rise over the run. The rise over run, which is change in velocity over change in time, giving us acceleration. So that does it for section. That does it for section 1 of ordinary level June 2018 physics. Ordinary level June 2018 physics. But stay tuned, as we will continue with section 2 straight away. We will continue with section 2 straight away.